So, hello everyone. My name is Florin Loghiade. I'm a principal site reliability engineer at UiPath. I'm also a Microsoft Azure MVP for over 10 years now. Being a Microsoft MVP doesn't mean that I work for Microsoft. It's something more of a community effort. It's something like, yeah, you guys are doing bad stuff, I'm gonna bitch about it. That's my job. And they gave me a title for that, and they even give me some perks because I am actually bitching about their products and services and what they're doing wrong. Actually, if it's 10 years now, I never said anything good to Microsoft about Azure. I always said something bad. So I know a lot about Azure. I have two titles basically in it. It's on Kubernetes and open source and platform as a service offering. So everything, mostly in Azure, that's what I work on. That's a little bit about titles. What I've been doing so far, it was something like, been doing reliability since I've never known about reliability, but I was thrown in the server space. So I started on premises, working with servers, working with racks, working with network switches and things like that. And in 3 years, I'm gonna have like 20 years of experience of not having good sleep at night. So this is something that I'm very passionate about. I'm passionate about sleeping at night and not being woken up at 4 a.m. to fix stuff. In the age of AI, it's something like they can fix the software problem, but you're never gonna have a robot plugging in your network jack. Never gonna happen. And yes, I've seen some extremely interesting outages in my life, like storage servers going down entirely, and you're just looking at it and cannot do anything about it. You're losing data, petabytes of data. So this session is about some of my experience, what I've seen so far about incidents, and the patterns that I've seen that you can see as well in preventing future incidents. So there are some incidents which are like near misses. There are some incidents that are very bad. But once you see some patterns in your applications, your Kubernetes servers, your whatever, then you can figure out, yes, that's going to outage, that's going to happen. I can try to prevent it or lower the risk of the blast radius. So, what you don't see during the outage, you see a ticket, you see a dashboard. Grafana dashboard, which has the SLAs going down. You have a channel, an incident channel with a lot of people which are screaming at each other, why is it down, why is it working, why it's not working, it's working for me, it's not working for me. Have you tried turning it off and on again? Things like that. You see a lot of chatter, chit chatter, you're not figuring out what's happening, and you're always fixing the mini issue with the problem. The mini issue is, okay, the pod is down, restart the pod. Maybe Kubernetes had a problem this morning restarting pods, but you're not looking at the problem, the root cause. That's the problem that always emerges. The root cause is something that always comes and bites you very bad. So you have a signal. In today's keynote, we saw a demo with a PVC. A PVC was missing, the pod was not starting. How about the PVC was deleted and the pod is not starting? Who deleted the pod? Well, we're working in AI era, so an AI thought it was a good idea to delete the PVC to make the pod work. So this is a signal. Now, the key takeaway here is don't always use AI blindly. Build harnesses around it and build hooks that block it from doing very bad things. It can go worse than that. I've seen nodes be deleted because of AI. And using whatever, ChatGPT, Claude, Gemini, whatever. They all do the same thing. You ask them to fix the problem, and they fix the problem. Not the way you like it, the way it knows how to do it. So, the idea is to move from the narrative to the signal. The narrative means the discussion. Let's figure out what happened now. But the signal is the thing that you have to look at most. The signal is, we have an increase in latency for whatever reason. You can say, oh, we have good business because people are using our service more. But is that so? Can be if you have a latency between the database layer or the storage layer or between Kubernetes clusters or other services, that can be a signal of a potential outage. You can say it's something small, it's gonna fix itself. That's where you have to look even better. So if you look at 12 months of data, you're going to see something very interesting. You see that at the beginning of the year, there are not so many incidents, and starting more and more in the middle, they start going up. And once they start going down, you have the peak, then you have the other peak. Now, if you look at the graph, if we look at the graph right now, March, 21 incidents. If we look at May, we have 46 incidents. If you ask me, and you might ask, are they related to the same services? Yes. Was that the same issue? Yes. Why did it explode? Because nobody looked at the signal. What was the actual root cause of the problem? It's like you have a switch, it's telling you that it's overheating because a fan might not work correctly, and you say, it's fine, it's gonna fix it, so I'm gonna blow some air in it. But you have to replace the fan. Once it goes down, it takes everything down because you didn't replace the fan. So that was the main idea. You look at the signal. Now, when you look at incidents, most people try to blame somebody or something. Usually you don't have time for that. You shouldn't do that, to blame somebody. It's a human mistake, and most of the problems are caused by pressure, deadlines, deliver now, agile. I have to deliver twice a week, 3 times a week. Now with AI, 60 pull requests a week. Why not? You're not writing the code, AI is just looking at the screen, so deliver more. So once you start delivering more, you have a problem in usually not code problems because the application crashes. Most of the good developers and even the not so good developers know to write some tests and to figure out the application. The problem is when you're doing changes. And you might ask, okay, change management? Nobody likes change management. You have a change management board meeting and you say, I'm going to change a switch in a cluster. Does everybody approve of it? No. I've been in those meetings. And those are words. Waiting 2 weeks for somebody to say, flip a switch on. No, we don't want that. Now, what you need to know, time to detect, there is something in SRE world called time to detect and time to engage. Time to detect is when you detect the problem. The time to engage is when you start working on the problem. What happens? When you engage, your phone rings, alert, bring your laptop on, join the incident bridge, you work on the problem, you fix it. The problem is the detection takes a long time to figure out that it happens. Most of the times happens because we set all our alerts low. Maybe our SLOs are more, let's not be woken up. Maybe with the severity of the issue is not finely tuned. So things like this happen because you have a very lax perspective of alerting. Now, I don't like alert storms. I've seen environments where you had 50,000 alerts per minute and environments with 10 alerts per minute. Which are the best? It depends. Why does it depend? Because if you have too many alerts, you start not looking at them. Everybody starts ignoring them. And I know a place, I'm not going to name it, it was sold, the supermarket. 60,000 alerts every 5 minutes. Right-click, read all, go away. Never happened. I've seen the 10 alerts. You had the very critical stuff monitored, but you didn't have the in-between. The in-between is the application is down. Nobody cares if the application is down. Is the server running? Yes. Good. Awesome. Anyway, now, these are the problems that I've seen so far. I've been doing this so many times and so much for so long time that these are the biggest ones. When you're doing a config or a deploy, that's when the outage happens. A feature flag was enabled, but it wasn't enabled in code. It was enabled in code, it wasn't enabled in the third-party dependency that manages the feature flags. That's one of the cases. The other cases might be you start working on a feature that requires another feature, it has a dependency between them, you deploy it, and you figure out in a multi-region deployment, let's say you have ring 0 up to ring 5, in a multi-region deployment, you saw that in ring 3, you never deployed what you needed, and it starts having an outage, and you ask yourself, it worked in Europe, it worked in Asia, it's crashing in US. Why? It worked perfectly. We deployed it 25 times so far. Well, oops, We didn't deploy the subsequent changes. And usually this happens because you have your CI/CD layer not doing a dependency check. What happens? Let's say you use Terraform. You need, let's say, a database for whatever reason. You need a database, but you need that database to be regionally based. Based on that, if the CI/CD doesn't trigger the Terraform to actually provision that database, you're going to have it done correctly in Europe, you're going to have it correctly in Asia. In the US, the Terraform pipeline never worked, it fails, and it creates an outage. And usually how I've seen these outages is one region is interconnected to other regions, and it's quite fascinating when you see US takes down Europe for whatever reason. They're segregated, they're separated. And if you've been in the last session when there was the talk about multi-tenancy and segregation and things like that, you think of, okay, how does this dedicated cluster take down the other dedicated cluster? Well, service meshes that are interconnect cross-tenant workspaces and things like that. So that's something that happens given the ideas. Capacity and quota. We don't work that much on premises anymore. If we would work on premises, you know how capacity works. We need more servers. You get a code, you buy the server, you provision it, it works perfectly. In the cloud, they're called hyperscalers. If we're talking about Azure, AWS, or GCP, or the others, we're going to have capacity issues. Now, in the AI era, we have a lot of capacity issues. These capacity issues are biting us in the ass. And I've seen it happen. We need a lot of GPUs, we don't have GPUs. We need a lot of compute, we don't have compute. Well, I'm paying for it, I have the quota for it, but they don't have capacity for it. So one of the problems that you have to deploy a server. Let's say you have 20 nodes, you need 40. Autoscaler works. Maybe you have a cluster autoscaler, maybe you have Carpenter, what doesn't matter. You know that we have load, that load increases, I need more nodes. What happens? An act of God happens because basically the data center went down and they don't have capacity anymore. They gave it to OpenAI. That's it. So that's something that happens. And if we look at Azure, Europe is at capacity. So they are trying to add more compute. They cannot supply the compute that we need, and usually for AI. They're telling customers, move from West Europe, that's Amsterdam, move to Sweden. But I have my full $500,000 footprint in West Europe. How can I move it to Sweden? And they say, such is life. Figure out your load better. Okay, fine. The other one is dependencies. Platform A depends on platform B depends on platform C, and you have this chain. If platform C goes down, platform A goes down. Where's the signal? Platform C has a criticality, because if all subsequent ones die, if it dies, all subsequent ones die. So where's the signal? If platform A has a dependency of platform C, what happens then? It happens something simple. You have a 500, a 403, an unauthorized, or 401, whatever. You have some HTTP codes. And it starts happening, and you're eating the silent errors. Those errors are the signal. Something is happening with platform C. What's happening there? You have to look at it. Because you say, my platform is perfect, it never has problems. When this goes down, all of us have problems. Imagine an identity server. Everybody uses identity. If the identity server goes down, you go back to sleep, basically. It doesn't work. Anyway, now, we cannot be happy if we don't have incidents. If we don't have incidents, that doesn't mean that we're good, we're great, everything is fine and dandy. We always have incidents. If we look at Anthropic, if you look at the status page of Anthropic, they have incidents like 5 a day. They have 5 a day, a lot of incidents. The problem with those incidents is that they manage them very fast. If you move as fast as possible, then you can understand perfectly what to do with that. Now, the absence of a signal is the bad problem. You don't know what's happening. And you can be extremely lax or extremely anal about it, to monitor a lot, but don't exhaust your engineers with alert storms, because they're going to start ignoring them. Now, something that we've been doing and how we've been treating these types of problems, and sorry for the black, I needed some black at least in the slides. If we look, this is an incident. Platform A had a P1. If we look at platform A, it has a JSON schema, so it's something custom built. With Claude, you can custom build whatever you want. You don't have to go in the market and buy something. Just build it. It's fine. Now, you have service A. You have a blast radius. Blast radius of service A, let's say it's identity. What's the blast radius of identity go down? Everything goes down. So that's the blast radius if you look at it. We can take it as tenant-wide, regional, or however we want to do it. Time to detect. We had a long time to detect. Why did it take 16,000 minutes to detect the problem? That's a big issue. What's happening? And usually these type of issues are detected by customers, which is the baddest thing. If you detect it internally and fix it before a customer wakes up about, oh, it's not working, did it happen? No. It happened internally, you never know about it. Time to engage, 3 minutes. So we are fast at fixing the problem, but we need to know the signal. The root cause, config change. And config change for the root cause, it can be the root cause, you can pull it from GitHub Actions, Azure DevOps, Jenkins. You can see it very clearly. We had a deploy 5 minutes ago, then the service went down. Okay, we have that signal. We know where the problem happened. Who opened the change? How long did it last? Who solved the problem? Then you can have some AI and say the confidence score. AI looks at the data, gives you a confidence score. I'm very confident that this is quite okay to write it that way. And then you have the minimal record, which is queryable. You can build dashboards, and then you can do something about it and not blame anybody. Now, when it comes to, okay, I cannot see it well on the screen. When we look at plumbing, we start from this part. We ingest a lot of information that is meaningful for us. And there's a lot of mean time to something. Mean time between failures, mean time to detect, mean time to recover, mean time to engage or mitigate. These are the things that you're interested in. If you have the mean and not average, average can be skewed by, I had an incident of 20,000 minutes to detect and one with 1 minute. What's the average? Well, a big one. So you're looking at a telemetry fabric that you can build. You take all the data from the entire tenant that you're managing. Can it be Azure, can be AWS, can be GCP. And from there, you pull all the data, you funnel it in this system. We call it a telemetry fabric. And then you can go to the second one, which is something called the narrator. The narrator is something that builds the postmortems. Anybody here built a postmortem or wrote a postmortem in their lifetime? Oh, yeah. Do you enjoy writing postmortems? You're a fluke. You guys are flukes. Anyway, we built something called the narrator. What happens with the narrator? The narrator does something very interesting. It pulls all the data, it pulls all the history, it pulls all the transcripts of the incident, and using AI, it does a pass, it does a second pass, it does about 3 passes to generate a postmortem automatically. It takes engineers 40 minutes to edit a postmortem, then another 2 weeks to build it and figure out. It takes them more to find the root cause of what happened, but they have all the data there. Okay, we don't have to write all the blurbs that we care about, or the leadership cares about, and things like that. No, AI generates the postmortem. We just look at it and say, yeah, looks good to me. Looks good to me. It added 50 tasks. Cut some of them down. We don't want 50 tasks on our sprints. We don't want that. We have 10. 10 is fine. It's good. We have the 5 whys. Okay, the 5 whys, it figured out this. You edit that. So from a, let's say, 5-page document, you edit this amount. And from there, you have what you need to have. How am I out of time? I'm good. Anyway, this is the narrator. We've been using it for more than a year. Engineers love it. The feedback was, okay, I don't have to write anymore. I was feeling like a professional writer, writing these postmortems and putting a lot of stuff like that. They got very lazy. And I myself am a lazy person. I hate being woken up. I hate working on problems that I know they should fix themselves. So I build self-healing systems. I try the alert to feed it to something else or delegate to something else so I don't have to do it. Imagine this. I've worked on-premises managing 300 servers by myself. You cannot do that without automation. So what I did, I added a lot of monitoring, a lot of metrics, a lot of scripts that were triggered by those metrics. And I never got more than 5 alerts a day because they were self-healing. And that's 2000 era, 2010 era. So it can be done in today's world with AI, and you can do it as much as you want. Now, I've said something about change management. Nobody likes a change management. If I say ITIL, some people will faint. I hate ITIL. In an ITIL meeting, it's something like, the system went down. What changed? I don't know. It changed something. It was something bad. Now, change management meetings, changes, approvals, documents. What's the risk of doing this deployment? In this today's day and world, we don't have 2 weeks to sit in approval meetings. We don't have that time. We have to deliver yesterday. So instead of change management, we have a change risk score, something that you're looking at on every pull request. You have a change risk score. What happens? We're doing something like we're changing something in Kubernetes. We're changing the ports of a service and something as a deployment, and you have a mismatch. Well, using some AI, it can figure out that, hey, this port 80 and this port 81, they don't match. You're changing them in the same time. What's the change risk score? Will it go down? Yes. That's red. Okay, so you have a system that flags red. It says, no, you're not going to deploy. This is going to take down the system very clearly. You have another one. You have yellow. I cannot know perfectly that this will take down the system, but this change has something systematic in it that might take down the system. Are you sure about that? I'm not going to block your deployment. Are you sure you want to go forward? Yes or no? Okay, go ahead. If it goes down, it goes on the record. Yes, you have a budget that you cannot do those deployments anymore. You have to be more careful. And green, well, you change the MD file. Nobody cares. Ship it. Anyway, the main idea is when you do a change risk score, you look at the prior incident count. So if that service, platform A, for example, had something like, I don't know, 20 incidents in a year, you give them a budget, 50 maybe. If you look at the 12-month rolling, how many incidents did they have? 25. Are they repeat offenders? Yes or no? Well, some of them yes, some of them no. Okay, bump up the number. Then you have the blast radius. How many changes did they do that affected the entire company? Let's say identity. How many times did identity take down the entire company? 50 times. No. Okay, you have to be more careful about that one. Detection coverage. Can you figure out in dev or staging that you're going to take down production? Yes or no? Well, yes, but no, because. Because of what? If staging is not the same as production, then we have a different problem to discuss. Staging should be the primary environment where you have to blast it. If it goes down, you know customers won't be affected. If customers come and tell you that their system is down, they're paying customers, you don't want to have that conversation. Now, rollback confidence. Let's say it passed all the smoke tests, the sniff tests, everything passed, but you have that little race condition that happens at a specific time. You never saw it, AI never saw it, nobody saw it coming. How confident are you in rollback? And how do you do rollback? Well, are you doing canary? Are you doing something else? How are you managing rollback? And you can do something like canary test, like you're moving 1%, 10%, 20%, and you do like a rollout over when you're doing the deployment. And when you go to 100% and 0 failures happened, then you can say this is going to switch like a flag. It goes to production, customers see the new version, everybody's happy. Is it foolproof? No. It will fail. Race conditions usually trigger when customers are actually doing stuff. The real QA is the customer, even though you might have a lot of QA engineers. That's the real QA. Microsoft found that out when they blew the QA team from Windows. So we are the QA for Microsoft. Anyway. Now, AI will not replace us. AI will make us better. Now, if we're not in line with how technology works or how it evolves, we're not going to have a Skynet like the first keynote session, but we're going to have a hard time finding jobs because we never started using AI, we haven't leveraged AI and not used AI sufficiently and smartly on how to do our job, augment us. We need to be augmented. Now, AI helps you find correlations. If you give it 50 data points, it can find correlations. If you give an engineer 50 data points, they might find the correlation. But if you have a number storm, you get lost in the big picture. They summarize, they draft, they suggest, they give you, but you need to do harnesses. Now, where do humans remain? We decide, yes, AI should do this with the proper harness. We own the action item. AI won't do the action item. We do it. We decide when we do something or we don't do something. We validate. AI is known to have errors. We call them hallucinations. If you ask an AI, what's the problem with this cluster, it's going to say, and you ask a subsequent question, are you sure? And you're like, no. Fact check. Yeah, I'm not sure about that. And if you ask the same question to the AI while it has that context, it's going to figure out that if you do like 10 iterations, you're going to have 10 answers in the same session. And who's the one that takes the decision? If you have the knowledge, you know the system, AI is going to give you the proof. You're going to say, okay, ship it, do it. I'm the one that gives the orders. I'm the fleet commander, not AI. AI is the executive, the one that executes. And be accountable. A name on every decision. We are accountable. We took this decision to use AI in that place. We chose AI to do that. We chose AI to do that. If we do it like this, we're fine. And we can find signals. We can prevent outages as much as we can. And when outages appear, incidents appear, we can know for a fact fast, okay, this is the problem. This is where I pinpointed. I detected it fast. Then I can solve it fast. Now, if you look at one page for Monday morning, this is the talk. What you should do, 10 things that you should do. Pull all your time to detect and time to engage data for the last 20 incidents. Find out what's happening and look at the outliers. If you have an incident for 20,000 minutes to detect, that's your first one you have to look. Why? Why did that happen? Then, 6 mandatory fields to your incident template. Use AI to build your incident templates and fill them. 6 mandatory fields, MTTD, MTTE, MTTI, MTBF. You decide. I'm not here to tell you what to do. I'm giving you the ideas of how to do it better, so you're not woken up at 4 a.m. in the morning figuring out, okay, I need coffee or not, I need to sleep, basically. Bless you. Tag services by layer. When you don't know what service is down, that's when you're losing a lot of time. If you know service A depends on service C, and service C is going down, then service A should know perfectly, I have an identity problem. It's not a service problem. So you can take the DRI, the responsible individual, pull him in from identity, you have a problem, because I know that. And we have teams that detect problems in other services before they know, like 20 minutes. So it takes them 20 minutes to figure out when this team said you're going to have a problem with that. Anyway, I'm almost out of time. I will take some questions. Now, this is the remaining slide. This is a suggestion from a friend. So the main idea is that you spend a quarter building a smoke detector, then you remove the battery. So I said, stop checking the battery. He said, you remove the battery. So we did a lot of work preventing incidents, preventing everything. Then we stopped looking at the signals and problems. With that said, thank you very much for being here. And have a great day. I have time for questions.
Thank you so much. So we have one more question before lunch break. Anybody has a question? Quick show of hands. Who is the first one? Oh, you're all hungry.
I'll be here for all.
You'll be here. So folks, then the way this works, we are now breaking for lunch. By the way, awesome talk. MTTB, MTTE,
MTTD, MTTE, MTTR.
Yeah, MTTR. I like meantime to relax.
Relax, exactly. Meantime to relax. That's perfect.
Exactly. So we break for 1 hour, and then at 2 o'clock, just so you know what's coming up, at 2 o'clock here, Adobe's platform story, a new platform paradigm for scaling the Kubernetes fleet. Obviously by Adobe, it's in the name. And the second one in the other room is going to be battery included AI platform from zero to production LLMs with EKS, Crow, and GitOps.
That sounds cool.
Enjoy lunch. See you later. Bye.
Thank you, folks.